Most of us are used to the AI lottery. You type in a vague one-sentence request and hope for the best. Sometimes it works, but more often you're left with a result that feels unpredictable and disconnected from what you actually needed. The solution is to move away from casual text entry. Instead, you can build a structural framework, a bulletproof, reusable prompt template that you can use for any recurring task. This template uses specific formatting and reasoning scaffolds. By organizing your instructions this way, you guide the AI to process information systematically, which helps align the model's logic with your specific goals. While this requires a bit of upfront work, you only have to build the structure once. From that point on, your recurring workflows are governed by a system you already know works. Let's look at a standard customer service task. If we ask the AI to write a polite refund email, we usually get generic, unusable text.
It's often too long, too formal, or just misses the specific brand voice. This is a zero-shot prompt. You are giving the model a command with no reference points, no history, and no examples to follow. The first upgrade is a few-shot prompt. Here, you provide the AI with just one perfect example of a past response that hit the mark. Seeing even one example helps the model immediately identify the precise tone, length, and formatting you require. When you provide a clear pattern for the AI to match, you take the guesswork out of the output and bring it much closer to your actual expectations. To make the template robust, we use the CoStar framework. This acts as a mandatory checklist to ensure you don't leave out any critical background information. You'll define the context, objective, style, tone, audience, and response. By addressing all six, you give the AI a complete map of the task. But dumping all this into a single paragraph will confuse the model. We need to use delimiters, visual markers that separate your instructions from the raw data. For models like GPT-4o, markdown hashes are the standard. Using triple hashtags allows the model to see your prompt as clearly segmented data. If you are using Claude, XML tags work even better. Wrapping your instructions in tags like context or instructions helps the model parse the prompt more effectively. When you pair the CoStar framework with these rigid delimiters, you create a machine-readable structure that keeps the AI focused on the instructions. Even a structured prompt can fail if the task is complex. If you force an LLM to jump straight to an answer, it's more likely to skip steps or make mistakes. Some users try to solve this by assigning a role, telling the AI it's an expert or a genius. While this helps with the style of the response, it doesn't actually improve the model's logical accuracy. To improve accuracy, we use chain-of-thought prompting. This forces the model to reason through the problem step by step before it delivers the final answer. This data shows that specific phrases, such as, "let's work this out in a step-by-step way," statistically outperforms standard human-designed instructions for reasoning tasks. You can build this directly into your template by creating a dedicated space for reasoning. Instruct the AI to show its work in a bracketed block before it writes the final response. This simple step drastically reduces the frequency of logic failures because the model is processing the why before it gives you the what. The final step is locking down the output format so the results are ready to use immediately without any cleanup. Add absolute constraints at the very end. Tell the model to respond in exactly 3 bullet points or to provide the output in a specific JSON format. To make this template reusable, we add an input anchor. This is a clear placeholder that indicates where your new data goes. By placing a header that says New Input at the bottom of your template, you create a simple fill-in-the-blank tool for your daily workflow. These final constraints turn the model into a precise engine that delivers exactly what you need, formatted exactly how you want it. Let's see it in action. We take a brand new scenario, paste it into our input anchor, and let the framework do the work. The model follows the few-shot pattern, runs through its reasoning steps, and adheres to strict output constraints. You can save this entire structure to your notes or your custom instructions. It's a logic-based framework that you can adapt to almost any task. Mastering this template architecture replaces the lottery approach with a repeatable system. It ensures your results are a direct product of the framework you've built, rather than a matter of chance.